Hi, in this video I'm talking about applying systems of linear equations. So there's 5 different methods of solving systems of equations that we've studied already in this chapter. So you have to decide which one is best depending on the problem that you're given. Alright, so substitution is typically done when one of the variables in either equation has a coefficient of 1 or negative 1. So substitution, so that's where you get one variable by itself and plug it into the other one. Elimination using addition is used if the coefficients of one of the variables are additive inverses. So like if you have 4 and negative 4, you would use substitution using addition. Elimination using addition. Elimination using subtraction is used if the coefficients of one of the variables are the same. So if like you have 4x and 4x, then you use elimination with subtraction. Elimination using multiplication is used when none of the coefficients are 1 or negative 1, and neither one of the variables can be eliminated by addition or subtraction. So when all the variables are different, completely different, you use elimination using multiplication. And for real world problems, it just depends on the situation given in the problem. So let's determine the best method to solve the system of equations in this system. Okay, then we're going to solve it. So all of the variables here, all the coefficients for the variables are different in this problem. So that means that we're going to use elimination using multiplication. So elimination by, and I'm just going to put this, multiplication. Okay, so now they want us to solve it. So I'm just going to make this little so I can get it out of the way and have more room to solve. All right, so we've got 2x plus 3y equals 23, and 4x plus 2y equals 34. So again, I already said that the coefficients for the variables are all different. So I want to find the least common multiple of either one of the variables so that I can eliminate it. So the easiest thing I think for me to do in this problem is to multiply the first equation by a negative 2, because that way I'll get negative 4x minus 6y equals negative 46 in the first equation. And then if I write the second equation as it is, you can see right here that I had negative 4x and a positive 4x now. So I can solve that system of equations. So the x's will eliminate. Negative 6y plus 2y is negative 4y. And then if I combine these, negative 46 plus 34 is negative 12. And then just to isolate the y, I divide both sides by the negative 4. And I get y equals 3, a positive 3. Okay, so now if I take that, I can plug it into either one of the equations in the beginning, so the original equation. So I've got 2x plus 3y, and we said y was 3, equals 23. Okay, so I'm using this first equation that was given to me in the problem. So I get 2x plus 9 equals 23. I need to subtract the 9 from both sides. So that cancels out. I get 2x equals 14. Divide both sides by 2, and I get x equals 7. So my final answer I'm going to write as a coordinate. 7 is my x, and my y is 3. So that would be my answer. In this problem, I'm given 4x plus y equals 32, and 3x plus 2y equals negative 6. Now, we know from working out all the problems in this chapter so far that I can solve a system of equations really by using graphing, substitution, or elimination. But in this problem, they're wanting you to say substitution because I have a y by itself here. So when I work out this problem, I'm going to get this y by itself. So to do that, I would subtract the 4x from both sides. So I would get y equals negative 4x plus 32. I'm doing this because I have a variable with a coefficient of 1. So when it asks you which way you're going to do it, you would say substitution. Okay. So now that I know what y equals, all this, I can substitute that in for this y. So I'm going to write 3x plus 2y, and y is negative 4x plus 32, equals negative 6. So after I do that, I'm going to distribute this 2, so I have 3x. 2 times negative 4x is negative 8x. 2 times 32 is 64. And that equals negative 6. So now I'm going to combine like terms. So 3x minus 8x is negative 5x plus 64 equals negative 6. Now I'm going to subtract 64 from both sides. And I get negative 5x equals negative 70. Then I have to divide both sides by negative 5. And I get x equals, that would be a positive 14. So, the easiest thing to do is to plug that 14 in right there. So I've got y equals negative 4 times 14 plus 32. So y equals, that would be negative 56 plus 32. So y equals, let's see, so 56 minus 32, 24, so that would be a negative 24. So my coordinate would be 14 for my x and negative 24 for my y. This next problem, it has 2x plus 2y equals 7 and 4x plus 2y equals 5. Now, you can see right here that both of my y's have the same coefficient. So when that happens, they want you to use elimination with subtraction. So if you have two coefficients that are the same exact number, they want you to use elimination with subtraction. So what that means is you can subtract one whole equation from the other. So I can subtract this whole thing. When I do, I'm just going to rewrite the first one, 2x plus 2y equals 7. And I'm going to distribute that negative sign. That's how you subtract it. So that would be negative 4x minus 2y equals negative 5. When I do that, 2x minus 4x is negative 2x. My y's would cancel out. 7 minus 5 is 2. So I need to divide both sides by negative 2, and I get x equals negative 1. Now I can plug that in either of the original equations. So I'm going to choose to do the first equation. So I get 2x, which is negative 1, plus 2y equals 7. So I am plugging this in right there. So that gives me negative 2 plus 2y equals 7. I'm going to add 2 to both sides. So I get 2y equals 9. Divide by 2, and I get y equals 9 over 2. So my answers are negative 1 and 9 over 2. There you go.